Hello everyone, I'm Wafula Alan Samuel, a physics math teacher, but today I'm going to be taking you in mathematics, and the theme of today we are going to be looking about is equation of a straight line. So by saying equation of a straight line. So today we want to look at how do we get the equation of a straight line. We should know very well that equation of a line, we are to use, or we have to first get the gradient of a line, because we know very well that the equation of a line is in the form of y equals mx plus c, whereby m is the gradient, c is the intercept or the y-intercept where this line meets the y-axis. So for us to get the equation of a line, we are supposed to first obtain the gradient. And if we have 2 points on that line, it becomes very easy. Take an example. If we have our 2 points P, and P is 1, 2, then Q it is 3, 4. And these are 2 points that are on a straight line. Then we need to get the equation of a straight line which passes through P and Q. So if I may sketch that line, you have maybe here P, which is 1, 2, and have Q, which is 3, 4. So we are required to obtain the equation of this line that contains P and Q. So what we are to do, we have first of all get the gradient of this line. And the gradient of this line is obtained by saying that the gradient, we call it grad of PQ, that the grad of PQ is change in y over change in x, which is the same as saying y2 minus y1 everything over x2 minus x1. So some would ask, what is x2, what is y1, what is y2? So what we do here, we go back to these given points, P and Q. We just label. We don't mind. It can be either, we can consider P to be x1, y1, Q to be x2, y2, or the reverse, by calling this one to be x1, y1, and then this can also become x2, y2. So if I decide, I can start by saying, let me call this point to be x1, then this one to be y1. Since we know that the first coordinate always represents the x, and then the second coordinate represents the y. So then here I will also call this one to be x2, then I note this one to be y2. Thereafter, I substitute this into my formula. So when I substitute in here, I remember that my y2 is 4, then my y1 is a 2, over my x2 is a 3, and my x1 is a 1. So when I subtract 4 minus 2, this gives me a 2. Then when I subtract 3 minus 1, I also get a 2. So this and this will give me 1. Thereafter, it shows that my gradient PQ is 1. And remember, we had said that our equation of a line, it is y equals mx plus c. So if I have got grad PQ, it automatically means that my m is known. So I will say, thereafter, my m is now equals to 1. Since I was saying that the gradient is represented by letter m. Then, after, I go back to look for the intercept c by saying, since I already have this equation, which is y equals mx plus a constant c, and I have already got m, whereby I know that y is the y coordinate, x is the x coordinate. So thereafter, I can either choose by taking p, or I can decide to use q. If I use p or I use q, I'll come up with the same equation. So it is just about me to decide of the two, which one can I take. So I can prefer take p or I can take q. So when I consider p, which is 1, 2, I'm going to take this as my x coordinate, and then this is taken as my y coordinate. So I substitute back in this equation. So this becomes 2 equal, our m, remember it was 1. It is here, m is 1. Then we shall multiply it by x. And remember our x here is also 1. then plus a constant c. So 2 will give us 1 plus c. So if I want to make c the subject, remember this is a 1. When it crosses equal sign, it must be, it will become a negative. So this becomes 2 minus 1 equals to 1 minus 1 plus c, whereby this 1 will cancel with that 1, and our value of c now also becomes what? 1. So after getting this 1, we go back and now restate our equation, and we say therefore our y equal our m, it is 1. Then our x, it is still going to be our x because this is the equation. Then plus the constant c, which we have got as 1. Because it will look bad if someone would say y equals to 1x plus 1. So whenever a constant or a coefficient of x is 1, we just ignore, but putting in mind that there is a silent 1. Or if someone couldn't use this equation, provided you have got the gradient as 1, we could also say, since we have already got our gradient as 1, and we have our 2 points, that is 1, 2, and our q is 3, 4. So I could also say, since this is our equation, so our straight line, and we have seen that that is p, which is 1, 2, and our q, which is 3, 4. I could get another point which may lie in between p and q, so I call this point r. Then I call this point to be having r. This is the point r which has a coordinate xy. Then I know very well that if this is a straight line, the gradient between p and r, r and q, or between p and q, and then p and r will always be the same since it is a straight line. So along the straight line, it has the same gradient. So I will start by getting the gradient between r and p by saying that if I can say gradient of pr, we know very well that it's changing y over changing x. So here now, I take this to be x1, then this is going to be y1. Then this is x2, and then this is y2. So this becomes y minus 2 over x minus 1. So this is the gradient of pr. But remember, I already had gradient of pq. So since I have known that this is a straight line, I can be able to equate, and remember I had got the gradient of pq as 1. So, since I've said that this is a straight line and the points along a straight line, they always have the same gradient. Thereafter, I'm going to equate the gradient of this to the gradient of this by saying it is going to be y minus 2 over x minus 1, everything equals 1. Then, I just put everything in brackets, I give this a fraction, then I cross multiply. That if I cross multiply, it will mean that this y minus 2 will multiply by 1, giving you x minus 1 multiplied by this one. So thereafter you see that y minus 2 plus 2 is equal to x minus 1 then plus 2. Since this is a negative, crossing cosine, it will give us a positive. So this will cancel. You find that y is equal a negative 1 plus a positive 2, it will give you a positive 1. And surely if you observe this equation with the other previous equation, you will come up with the same equation. No matter the method you have taken, you will end up having the same answer. Then sometimes we can also give you a point. For example, I can give you a point P, which is let's say 1, 2, and automatically I give you a gradient M, maybe it is equal to a half. Then I say, find the equation of a line that passes through a point P and has got a gradient a half. So once you have been given this, a student should not now start asking, I don't have a second point. Already you have a gradient M. You have a point. So a student, what he will do, will just go direct. You have already got a gradient and you have already got a point. So you just start by saying this is now your x, that's your y. So thereafter, we shall just go back to this equation. Y equals mx, then plus a constant c. But remember, our coordinate on the y coordinate is 2 and the x coordinate is 1. And already our m is known as a half. So a student will just substitute in for y as 2 equals to our m, which is a half, multiplying it with x, and our x is also 1, then plus c. So you'll find that 2 is equals to a half, then plus c. Then when you reach here, how would you get the value of c? So what you do, you make everything linear by multiplying this side by 2 Also multiply this side by 2, this side by 2. Multiply everything by 2. You find that this 2 will go with that 2. Then 2 times 2 get 4, which will give us 1, because here remaining with the 1. Then plus a 2c. So you'll find that to make c the subject, this one will have to cross equal signs. When it is a positive, cross equal signs, you have seen that it becomes a negative. So this becomes 4 minus 1 equals to a 2c. Then after here you get 3 equals to a 2c. So dividing both sides by 2, both sides by 2, you'll end up having that the value of c is 3 out of 2. So since you already have the value of c, you already have the value of m, you therefore just go back and substitute in this equation. So when you substitute in, we have already seen that our m is a half, and we have seen that our intercept is also 3 over 2. Implying that we shall therefore say y is equal to a half, then x, then plus 3 over 2. A student may stop here or may make it linear by multiplying through by 2. And when you multiply through by 2, you find that this is 2 times y equals 1 over 2x, then times 2 plus 3 over 2 times 2. Whereby you will see that this will cancel with this, then also this will cancel with that. And here you have 2y equals to x, then plus a 3. And this becomes the required equation of a line. In case you are given a gradient, the way I've showed you, and a given point. Then sometimes also you find that a student may be given a complicated fraction. For example, our point A, it is a negative 2, 1 over 2. And maybe here it is just 1 whole number, 1 over 4. Then our point B, which is also maybe negative 1, 1 over 3. Then 1, 2 over 3. Then they tell him or her, what is the equation? Or find the equation of a line that goes through A and B. Now, it is a challenge to some of the learners when it comes to changing this into an improper fraction. Because a student will think that you multiply 2 times negative 2, then add it 1, which will give you a wrong answer. So a student in this level must first observe as if this negative is not there, multiplies 2 times 2, which gives a 4, add it to a 1, which is a 5, then releases this negative to give negative 5 over 2. Then for this, it is obvious, it is just 4 times 1, which is a 4, plus 1, which is 5 over 4. Then here, we also simplify it by saying B, the same that we have done here, it could be the same here, by saying it is a 3 times a 1, then plus a 1, ignoring this negative at the first case. Because if you bring in a negative, like for example, I say 3 times a negative 1, it will give us a negative 3. And a negative 3 plus 1, it will give us a negative 2. And a negative 2 over 3, surely when you try to divide it, it cannot bring you back to this mixed fraction. So it is always advisable for a learner to know that this negative affects the whole of this fraction, not only this one. So to handle this, we assume as if this negative is not there, then we multiply. After multiplying, we bring in a negative, which will also give us negative 4 over 3, and thereafter this also gives us 5 over 3. So after reaching this level, it also becomes easy for a learner to identify that now here, I'm not dealing with whole numbers, I'm dealing with fractions. So care must be taken. If need be, LCM must be put in mind, knowing that this is also going to be my x1, y1. Then this is x2, y2. Therefore, you will also do the same by saying gradient of AB will therefore be equals to changing y, which is y2 minus y1 over x2 minus x1. And since we have known that our y2 is 5 over 3, and our y1 is 5 over 4, so a learner will still proceed to say it is 5 over 3 minus 5 over 4, everything by negative 4 over 3 minus 5 over 2. So after reaching this level, a student should also know that whenever you have a negative with another negative, these two negatives will cross to give you a positive. Then at this level here, remember, we had just 5 over 3 minus 5 over 4. Since these ones don't have the same common base, what we shall have to do is to get the LCM. In the numerator, first of all. So therefore, when I squeeze it here, you'll find that the LCM of 3 and 4 gives us a 12. So we shall first put the 12. Then a 12 divided by 3 gives us a 4. Then a 4 times the 5 gives us a 20. Then minus A 12 divided by 4 gives us a 3. A 3 times a 5 gives us a 15. But remember, we have a common denominator, which is also having a fraction. So down here, it has a different LCM. And the LCM here is also a 6. So we shall get a 6 divided by 3, which will give us a 2. A 2 times a negative 4 gives us a minus 8. Then plus, we get a 6 divided by 2, we get a 3. Then multiply it by 5, which will give us a 15. So after reaching that level, we just need to know that we have to simplify the numerator alone, the denominator also alone. By saying 20 minus 15 gives us a 5 out of 12. A 5 out of 12. And also here, negative 8 plus 15 will give us a 7 over 6. So we have seen that this is a 5 out of 12 over a 7 out of 6. So this is what we had got, the numerator and the denominator. So we therefore apply what we mean by BODMAS. So here we shall say it is 5 out of 12. Now we are dividing by 7 over 6. So which is the same as 5 out of 12. We just now multiply, the 6 goes up, the 7 goes down. So we can see that some 6 can reduce this 12 to give you a 2. And therefore 5 times 1 gives you a 5. And then a 2 times 7 gives you a 14. So therefore the gradient this time becomes a fraction, which is 5 out of 14. So after getting 5 out of 14, we are required to look for the intercept, and that is our c. But remember our equation, it is y equals to mx, then plus a constant c. And when you go back to our equations, when you go back and see, this is the point given us, we had been given this and that. But remember, we had changed them into improper fractions. So I can either choose B or I can choose A. Since I've been choosing the first point, this time I will choose the second point. So when I choose this second point, which is a B, and that is negative 4 over 3, 5 over 3. So I'm using now I'm using the point negative 4 over 3, 5 over 3. Remember that was our B point. So still, this becomes X, this becomes Y. Now, this time, we have to say, from this equation, our gradient is known, our X is here, our Y is there, so it will become 5 over 3 equal to our M, which is 5 out of 14. It's multiplying with our X, which is negative 4 out of 3. Then plus a constant with the y-intercept. So from here, it becomes 5 over 3, which is equal. So here there's nothing which can simplify. So we just, actually this 2 by 4 can reduce this, which is now a 2, and then this is a 7. So we find that 5 times negative 2 gives us negative 10 over a 7 times this, which gives us 21. Then plus c. So after doing this, we just now carry this, bring it this side, by saying it is 5 over 3, a negative positive cosine, we see that it becomes the positive, so plus 10 out of 21, which will give you equals c. The LCM this side, it is still 21, because the 3 and 21, LCM is 21. So 21 divided by 3 is 7. 7 times 5, you get 35. Then plus 21 divided by 21 is 1. Then plus, times 10, you get a 10 equals a c. So 35 plus 10 gives us 45. So therefore, you see that our C becomes 45 out of 21. So we had got already our M, which is already here. Now we have got our C, which is already here. So what we are required of is to just get the value of C and the value of M, put it in this equation, and that gives us the required equation of a straight line, which would therefore say Y is equal to our M, which is 5 out of 14, but remember with X, then plus our C, which is 45 out of 21. I can either leave it at this level or I can make it linear. So since the fraction looks bigger, I can decide to leave it at this level, and therefore this becomes the equation of a straight line. Then, after I've got this equation, there are many questions you can ask you, because our theme today is how do we get an equation of a straight line. So, and this requires, or this gives us the required equation of a straight line with the first example we saw. Thank you.
Now,
This have been Wafula Alan Samuel teaching you mathematics, and more videos if you want to watch. Go and subscribe to our academic for more videos which you always post, and you'll be educated more and more. I remain Wafula.